Hello friends, myself Shriram Kurde. I welcome you all to Introduction to Java. So this is our initial session where we will get an idea about what is Java, what is the history about Java and things like that. So without further delay, let's get into it. So as part of introductory video, one needs to understand a quick overview about history of Java. Then what are the important words which are typically referred as buzzwords which are part of Java, and then one needs to understand the object oriented paradigm, and then how do we write a simple Java program. So these are some of the important contents which basically are part of introduction to Java. So let's understand the history of Java, because a lot of people are interested in knowing the history of a particular topic. So let's get a quick overview about the history of Java. So when we talk about the history, for that matter a history of any particular language, then we are aware that the language evolution has happened. Like initially there was a basic language, then Pascal language, and C language, C++, like that. So the history says that there are two reasons that a language is introduced when it comes to computer programming language. The first reason is to adapt to the changing environments and uses. The second one is basically about the improvement in the art of programming. Now, when we talk about adapting to the changing environment, that means the overall environment where you are trying to develop various programs, that itself undergoes change. Say for example, your hardware undergoes a change, its capabilities undergoes a change, like your processors undergoes change. Like for example, we were having say I86, then essentially like 386 or 486 processors, then Pentium, dual core, and then like things like i3, i5, i7, and all that, which we see these days. So essentially, the environment itself, when it comes to hardware, that is changing. Apart from that, the more the complexity gets added to the software, the art of programming also needs to undergo change. Like for example, people were earlier coding in say, assembly language. Then assembly was able to cater to say few lines of code at in one go, or say some few thousand lines of code I can say. However, that was not enough, because as more and more complexity got added into software or in the programming, then basically the evolution has happened, and then the programming language has happened. That means to implement improvements in the art of programming, like for example, you have a structured programming, and then from structured programming there is say object oriented programming and things like that. So these are primarily the two reasons where like computer language innovation happens. These are just sort of I will say two broader thought process, and which are key process or key points when it comes to innovation and development which happens with respect to the computer language. And both these points affect in equal measure. Now when it comes to Java, needless to mention, the features that are part of Java language are inherited or are inspired from the earlier language. Like for example, people used to use basic language, then C. C is predominant still, and it's part of core programming still today. So basic C and C++, obviously C++, when we say C++, again C happens to be part of that, and then from C++ the evolution towards the Java language. So now when we talk about Java, the first important language that plays a role and still plays a role is C language, which was basically given by Dennis Ritchie in roughly around 1972-1973 time frame. Before C, there used to be programming languages like BASIC, COBOL, Fortran, Pascal. Fortran still plays an important role when it comes to scientific computing. So when it comes to C per se, then C basically is a high level language, and that could replace the assembly code when creating the systems program. The reason is because you can't write assembly programs very easily. One needs to understand the architecture of the processor, one needs to be aware of the assembler and things like that. So obviously you require a high level way of writing a program, and that's where the C has fits in. And basically C is extremely good when it comes to handling those aspects of systems programming. And needless to mention, one needs to have large pool of programmers. You can't have large pool of programmers in assembly code. The important reason that C is successful is designed and implemented and tested by programmers. That means it has tested the test of time. That's the way typically people say. Now when it comes to another language before Java, C++, so essentially it was given in 1979, which was given by one of the key person, and that is Stroustrup. And the main reason that C++ was invented was basically to improve on the programming aspects, that means the programming paradigms, because the complexity of programs has increased. Because C could cater to several thousand lines of code. However, certain limitations of within C, say for example, everything is public sort of situation, like everything is global, though there is no public in C, but everything is global. So that leads to a lot of complexities and lot of issues when it comes to maintaining the code base and handling or writing the complex programs. So to respond to the increased complexity of programs, people have come out, or the Stroustrup was one of the important person in that, and they came up with an object oriented paradigm. So typically when it comes to programming paradigms and methods, that means the improvement that has happened is like the assembler languages, then the high level languages, then the structured programming, and then came the object oriented programming. That's what I just mentioned. Like you have assembly programmers, then you have say C programmers. Obviously there are Pascal programmers, Fortran programmers, and then when it comes to C, people basically wrote structured programming, and that is very good, and that continues to play. C plays a very important role when it comes to systems programming, like drivers and things like that. And then obviously they have added object oriented features or object oriented paradigm, and that's where the C++ was has come. So object oriented methodology basically helps to organize complex programs through the use of key features like inheritance, encapsulation, and polymorphism. So we will study these things as we proceed forward when we reach Java. So typically in nutshell, C++ extends C by adding object oriented feature. So many times it is referred as C with object oriented features, typically becomes C++. So now comes the Java. So that will be dealt as part of the second session, where we will understand little bit about history of Java, because now we have understood little bit about C and C++. So now we will need to understand the history of Java, and then obviously the features or the important buzzwords and how do we write Java program as part of the next session. So this was just a preliminary session. Thank you.